It's known as Springer's theorem. So another way of saying it is that if a quadric hypersurface has a zero cycle of degree 1, then over a field K, then it has a K point. So if 3 is replaced by 2, then one can remove this conjecture, and this becomes a theorem that if one wants to make the first coefficient and the second coefficient 0, that can be done if and only if n is either a power of 2 or the sum of 2 powers of 2, which is the same thing in that case. But for n equals 3, I don't know the answer. So let me stop here. Thank you. So the only case, well, there's a weaker result for surfaces due to Daniel Correa. It says that if there is a zero cycle of degree 1, zero cycle of degree 1 is the same thing as a point of degree prime to 3. Right, because there are plenty of points of degree 3. Cycles of degree 3, one can just take a line and take the intersection with the cubic. So if there is a zero cycle of degree 1, then there is an L point where L is an extension of degree 1, 4, or 10. So one can reduce the degree of a point. If it's prime to 3, one can reduce it to 1, 4, or 10. And there have been repeated attempts to remove the 4 and the 10, and they've all failed. And that's only for surfaces, and in higher dimensions, I don't know. I mean, this, of course, this just to put this in perspective. So here, Hermite's theorem is for surfaces, and Correa actually proved Hermite's theorem using these methods. And then that's for n equals to 5. For n equals to 6, Robert's theorem is for 3-folds. So the first case that's of interest to me is in dimension 4. Yes. Yeah, so this hypersurface, so if one splits this extension, goes to the algebraic closure of K, then it becomes the same hypersurface that it's this. So it is smooth if n is odd. If n is even, it has isolated singularities. So these are points where all the coordinates are plus or minus 1, and the number of plus 1s is the same as the number of minus 1s. And these singularities are actually used in a crucial way by Correa in his proof in the case where n equals 6. So he was able to handle this particular cubic just because he was able to use these singularities. But I'm certainly happy I would be happy to do something in the case where n is odd, where this is indeed singular. Is indeed smooth. Yes?
Would it be reasonably possible to make this variety in which instead of 2 of the power functions vanish, you have 3 or more? Like in this case, the first power and the third power. And you can ask the same question for other functions.
Yeah, one can choose any collection of coefficients and ask for them to be 0, or one can take any power functions and ask for those to be, so there are lots of questions of this type. And that was the reason why I was dealing with the transcendence degree. So that formulation of the problem is a little bit more natural, maybe. But these questions become more difficult. So just to step back from this a little bit. So the issue of when there is a zero cycle of degree 1 is sort of tractable in this case. So assuming that we can answer that question, then we are asking, well, if there is a zero cycle of degree 1, can we conclude that there is a rational point just on an arbitrary variety of an arbitrary field, right? So that, I think the answer is usually no, even for curves in higher genus. But for things that are rational or rationally connected, or maybe if the variety is a homogeneous space, those questions become more plausible, at least. And for homogeneous spaces, they have been investigated quite extensively. It's still, so for homogeneous spaces, there's some counterexamples, right? But quadrics are homogeneous spaces, and there the answer is yes. So cubics are kind of in between. So they're not homogeneous spaces, but they are unirational. Well, geometrically unirational, and so it's not clear which way they're going to go. For cubic curves, this is true, by the way. So if one increases the degree, then I think this connection between a zero cycle of degree 1 and a rational point becomes weaker. So then there's no reason to expect that those two questions will be connected. That's what I'm saying. So that's what makes these small degrees more tractable, perhaps. But you're right, the question can be asked. And my method for the negative answer works for any prime. So for if the A1 and AP are required to be 0, then that fails. That can't be accomplished if n is a power of p or the sum of two different powers of p. So that is not specific to 3.
If there are no other questions, let's stand for this moment.
I'll start to mention brief announcement for Tulane. So next talk will be here at 2 o'clock. For food, the faculty club at the end of the hallway here. And the price is $11, and of course there is food court downstairs. I recommend this one over here in the second floor because
are we allowed to go? We are not separating.
yes, that's fine. Yes, they don't ask any money except undergraduates. they think that they're an undergraduate and they may not allow. Otherwise, they don't ask you questions. So I recommend it. It's about this side and